Hi, welcome to today's session on similar shapes ratio. So what we are looking for when we are talking about the ratio is we are looking for the ratio between corresponding sides. Now here I've got two triangles where I've listed the names of the sides where we've got our opposite. We've got our hypotenuse, which is the longest side. Our opposite is opposite our angle given. And we've got our adjacent sides. I've just used the names of the sides just so we can give some definition to what we're going to do in just one moment. But as you can see, each one of these sides as well has got a length. So when we are looking at similar triangles, which is exactly what these are similar triangles because one's an enlargement of the other. We are being told that one of the angle is 37 degrees, in which case we know that the other angle in both of these two shapes has got to be 180, taken 90 away, taken 37 away, because both of these have also got a right angle. So they have got to be similar. Now the ratio of each side, if we was to look at the opposite over the adjacent, so 3 divided by 4, that is going to equal the exact same as 6 divided by 8. So we've got the exact same ratio between the sides in our original shape and in our enlarged shape. Exactly the same for the opposite and hypotenuse. So 3 divided by 5 will give me the exact same result as 6 divided by 10. And our last one, we've got adjacent and hypotenuse. 4 divided by 5 will give me the exact same answer as 8 divided by 10. In which case, we're just using ratios to maybe find missing sides. So we can use this idea for when we are working with maybe harder looking questions. So here we've got a problem, and here we're going to use a bit of proof writing as well. So here we've got a diagram, we've got a triangle A, B, C, and we've got triangle A, D, E on the outside of this. We've been given some lengths, and we've been given two things to find. We've been asked to find what length AE is, and find out what the length of BC is. So using the information given and using our ratios, we can actually calculate this. So if we use that AD divided by AB, the ratio of this has got to be the same as the ratio of this. So AE, the bigger length on top, because we're using the bigger length on top on what we're looking at for our ratio, and AC underneath. So this means we've got 10, because 8 plus 2 gives me 10, over 8 is going to equal AE, which is what I'm looking to calculate, over 12, which is AC. Now rearranging this, taking my 12 from the right hand side, taking it to the left hand side, it's divided on this side, so it'll become a multiply on this side, and then dividing it by 8, AE is going to equal 15 centimeters, which also means that the gap between CE, or the length of CE, is going to be 3 centimeters. Now I'm going to use the ratios again to find out what BC equals. So I'm going to use the ratio of, yet again, of AD over AB. This is natural because I've already gone and calculated this, so it's a nice easy one to use, which is going to equal the ratio between DE over BC. So here I've got 10 over 8 equals 20 over BC. Now rearranging this is going to give me BC equaling 8 multiplied by 20 over 10. So dividing this through, this gives me a length of 16 centimeters for BC. So using a bit of proof writing and using the ratios of given sides within our object and our enlarged shape, we can find missing sides. If you like what you see, please subscribe. Thank you very much for watching.